48 years in space, more than 24 billion kilometers from Earth. Voyager 1 is still alive, sending back whispers from the edge of the galaxy. This spacecraft has outlived the Cold War, the invention of the internet, and even many of the people who built it. It's the most distant human-made object in history, but how does it still work? What mysteries of interstellar space is it revealing? And how much longer can it survive before the silence finally comes? Welcome to Space and Joy, where we explore the wonders of the universe. From mysterious comets to distant galaxies, black holes to the latest space discoveries, we cover it all. Subscribe and join us, and let's dive into the wonders of space together. Let's dive into the video. Voyager 1 launched in 1977 alongside its twin, Voyager 2. Originally, it was part of a 4-year mission to explore Jupiter and Saturn. But its discoveries rewrote textbooks. Voyager gave us the first detailed images of Jupiter's Great Red Spot and revealed volcanic eruptions on its moon Io. At Saturn, it discovered complex ring structures and moons like Titan, shrouded in thick atmosphere. After its planetary encounters, Voyager kept going. By 1990, it had already sent back the famous pale blue dot photo, Earth seen as a tiny pixel against the vastness of space. In 2012, it became the first spacecraft to leave the heliosphere and enter interstellar space. Today, it is more than 166 astronomical units away. For context, if Earth were a one-step walk, Voyager 1 would be more than 4 miles down the road. Operating Voyager is like maintaining a 1970s computer with limited memory and ancient hardware, from over 15 billion miles away. The spacecraft has only 68 kilobytes of memory, less than a single photo on your phone today. In late 2023, a critical memory chip failed, scrambling all telemetry. Many feared this was the end. But in April 2024, NASA engineers reprogrammed Voyager, redirecting the data flow away from the damaged section. Against all odds, the spacecraft began transmitting usable science again. Then, in May 2025, they faced another problem. Voyager's antenna must stay precisely aimed at Earth, or its faint signals vanish into space. The thrusters responsible for this had degraded. Engineers reactivated backup thrusters that had been dormant since the 1980s. To everyone's surprise, they fired perfectly, keeping Voyager aligned. These miracle saves demonstrate not just technical skill, but the determination to keep a scientific pioneer alive. Voyager 1 is powered by a radioisotope thermoelectric generator, or RTG. It converts the heat of decaying plutonium-238 into electricity. At launch, it produced about 470 watts. Today, it produces just around 250. Each year, the output drops by about 4 watts. This slow decline is forcing NASA to make tough choices. To conserve power, heaters for instruments have been shut off, leaving them to survive in freezing conditions. One by one, science instruments have been switched off. In February 2025, the cosmic ray subsystem was deactivated after nearly 5 decades of operation. It had measured galactic cosmic rays, helping us understand radiation hazards for astronauts and spacecraft. Now only 3 instruments remain alive. 3 instruments continue to send back science. First, the plasma wave subsystem. This listens for vibrations in the thin gas between the stars. By analyzing these plasma oscillations, scientists can measure electron density directly in interstellar space. Second, the magnetometer. It measures the shape and strength of magnetic fields around Voyager, giving clues about how the sun's influence blends into the galaxy. Third, the low-energy charged particle instrument. This tracks cosmic particles from the sun and beyond, revealing how radiation moves through space. Together, these instruments are creating humanity's only in situ map of the local interstellar medium. Recent peer-reviewed papers confirm Voyager's plasma wave data is consistent with galactic models, showing regions of dense plasma as shock waves from the sun ripple outward. Voyager's data is more than numbers. It is the first real look into the environment between the stars. Understanding interstellar plasma density helps us model how the galaxy interacts with our solar system. Measuring cosmic rays tells us how much radiation future astronauts might face on interstellar journeys. Mapping magnetic fields explains how the heliosphere, our sun's protective bubble, shields Earth from galactic radiation. Without Voyager, we would be guessing. With Voyager, we have direct evidence. NASA expects Voyager 1 can keep at least one instrument running into the early 2030s. By then, only the most power-efficient detectors will remain active. Around 2035 or 2036, even communications may cease as the RTG output becomes too low to run the transmitter. But Voyager will not stop. It will continue drifting silently through the Milky Way, carrying the golden record, a time capsule of Earth's sounds, music, and greetings in 55 languages. Long after its last signal fades, it will remain a symbol of exploration. Voyager 1 is more than hardware. It is a story of human curiosity, persistence, and creativity. Built with 1970s technology, it has survived longer than anyone predicted. It has crossed a boundary no other probe has reached. It has sent back images and data that change how we see ourselves. When Voyager finally goes silent, it will still carry the message that humanity once reached for the stars. And that message will keep traveling for billions of years across the galaxy. Even after nearly 5 decades, Voyager 1 continues to extend humanity's senses into the unknown. You can track its live position today through NASA's eyes on the solar system or the sky live. Voyager proves that even our oldest machines can still make history. Thanks for watching.